All right, so let's look at a heating curve problem. So we're looking at how much heat energy does it take to take 15 grams of solid ethanol at negative 114.5 degrees Celsius. We're going to heat that up, so we're going to melt it, turn it into liquid ethanol, and then get it up to gaseous ethanol at 158.5 degrees Celsius, right? So it's kind of like I got ethanol as alcohol, right? So some solid alcohol, and I am adding energy to melt it and then turn it into a gas. So that heat of fusion, the energy it costs to melt or unmelt ethanol is 4.6 kilojoules per mole. Molar heat of vaporization, how much energy does it cost to vaporize, turn it into gas, 38.56 kilojoules per mole. It's got a melting point at negative 114.5 degrees Celsius and a boiling point at 78.4 degrees Celsius. And then it gives us our specific heat for liquid ethanol and gaseous ethanol. So notice it didn't give us specific heat capacity for solid ethanol, and that's because we start this problem right at that melting point of ethanol, negative 114.5 degrees Celsius. So we start with this ethanol that's right at that point where it is about to start turning into a liquid, and so we have to figure out how much energy does it cost to turn it into a liquid. Well, we have that heat of fusion, 4.6 kilojoules per mole. We just need to multiply it by the number of moles. That's going to be our first chunk. So that gets the ethanol melted. Now we're taking that melted ethanol, and here's chunk 2. We are going to take our formula Q equals M times specific heat times change in temperature, because we're taking that liquid ethanol and we are raising its temperature up to 78.4 degrees. So then our third leg of this heating curve, so we take that liquid ethanol up to the point where it starts to evaporate, and now all of that energy is going to be given to evaporating the ethanol. And so we're just going to take the number of moles of ethanol and multiply it by that molar heat of vaporization. And so that will get our ethanol completely turned into a gas. That's how much energy it takes to turn that ethanol into a gas. And then our final leg of this problem is going to be another taking this gaseous ethanol and heating it from its boiling point at 78.4 degrees Celsius to some final temperature at 158.5 degrees Celsius. And so then if I just look back at these equations, well, looking at leg 1, right, that's when I'm taking the solid ethanol and I am melting it, I'm turning it into a liquid. Well, here it gives me a mass of ethanol. I don't have a number of moles. And that heat of fusion is given in kilojoules per mole. So I need to be working with moles of ethanol for these heat of fusion and heat of vaporization parts of these problems. So I'm going to turn this into moles. I just use the molar mass of ethanol. If you're not familiar with ethanol, it's C2H5O5. It's ethane with an OH group attached onto it for those of you who are going on to organic. And so this will tell me how much energy does it cost to melt the ethanol. And it will give me an answer in kilojoules, right? Notice I have kilojoules here. The problems, my leg 2 and leg 4, I'm going to actually have an answer in terms of joules. So I'm going to need to either convert the answers I get in kilojoules to joules by multiplying by 1,000, or I need to convert the answers I get in joules to kilojoules by dividing by 1,000. And so you'll have to look on this problem whether it wants you to report your answer in joules or kilojoules. And your numbers might not be the same for this specific homework problem. And so that gives me, right here, 15 grams of ethanol times that specific heat of liquid ethanol times that change in temperature. That's how much energy it costs to heat up the ethanol, right? And then third step, right, I need that number of moles again because I need to figure out how much energy does it cost to turn that ethanol into a gas in this leg, right? So I'm taking, again, that 15 grams of ethanol, that molar mass of ethanol, and I am converting it to moles, and I am multiplying by that molar heat of vaporization. And so leg 4 of this problem, I am taking that ethanol that has been evaporated at 78.4 degrees Celsius, and I am now heating it up. So I'm taking another Q equals mass times specific heat times change in temperature. 15 grams of ethanol at a specific heat of 1.43 because it's gaseous ethanol times that change in temperature. Right, so anytime you're setting up these kinds of problems, we had the water problem on the homework. We went back a little further, right? We had before, we had to look at getting up to that melting point, but that's not always the case. We need to look at what the boiling and melting point of our substance is. And so all you need to do there is pick whether you want kilojoules or joules, convert all of your answers to the same unit, and then just add them together. And that tells you how much energy does it cost to bring 15 grams of solid ethanol at negative 114.5 degrees Celsius to a gas of ethanol at 158.5 degrees Celsius.